In a first, the James Webb Space Telescope may have glimpsed a rare type of star that astronomers aren't even sure exists. These stellar objects, called dark stars, might not have been fueled not by nuclear fusion, but by the self-annihilation of dark matter, the invisible stuff that is thought to make up about 85% of the matter in the universe. The candidate stars seen by JWST will need more evidence to be confirmed, but if they're real, the finding could change our story of how the first stars formed. Contrary to their name, dark stars could typically have glowed 1 billion times more luminously than the sun and grown to 1 million times its mass. Dark stars have never been definitively observed, but cosmological simulations suggest that they should have formed soon after the Big Bang from clouds of pure hydrogen and helium that collapsed at the centers of protogalaxies rich in dark matter. Now, researchers report in the Proceedings of the National Academy of Sciences USA that at least 3 far-off objects observed by the JWST and previously identified as galaxies could, in fact, each be single, supermassive dark stars. If you find a new kind of star, that's huge, says study co-author Katharina Friese, an astrophysicist at the University of Texas at Austin. The researchers can't yet prove that the objects are dark stars, only that their characteristics are consistent with being either dark stars or galaxies populated by regular fusion-powered stars. JWST's technology is sufficient to do that job. However, says study co-author Cosmin Ely, an astrophysicist at Colgate University, all researchers need is more observation time. We hope we are going to find one of these dark stars with the Webb within its lifetime, Ely says. There are 2 possibilities for how the first stars in the universe formed. The conventional wisdom is that these early stars were population E stars. Such stars would have been powered by nuclear fusion, like stars today, but they would have had very little to no metals in them. In astronomy, that means elements heavier than helium, because those elements had not yet formed in the early universe. There is another possibility, though. In 2008, Friese and some of her colleagues proposed that the universe's first stars could have been powered by dark matter. Dark matter is a mysterious form of matter that does not interact with electromagnetic forces. Scientists only know it exists because of its gravitational effects, and they don't know what it's made of. In the early universe, dark stars could have formed from the collapse of helium and hydrogen clouds made in the Big Bang. If dark matter particles are also their own antiparticles, as many dark matter theories posit, then within these collapsing clouds, those particles would have collided with each other and self-annihilated. The collision would have kicked off a chain of particle decay that ended with the production of photons, electron-positron pairs, and neutrinos. Only the neutrinos would have really left the cloud, because they barely interact with matter. The other particles would have hit the hydrogen and helium and transferred their energy to this matter, which would have heated up the cloud and fueled the star's formation and continued growth. These stars would have formed at the center of mini-halos, which were early protogalaxies that existed 200 million years after the Big Bang, before the advent of elements heavier than helium and hydrogen. These mini-halos consisted almost entirely of dark matter, making conditions ripe to power the dark stars. This high concentration of dark matter is why dark stars could form only in the early universe, Friese says. Because the stars would have been relatively cool and would not have emitted the high-energy photons that nuclear fusion-powered stars do, they could have kept adding mass, causing them to swell larger and larger over their lifetimes. Now you've got a weird thing, Friese says. It looks like the sun in terms of its surface temperature, but it's 1 billion times as bright. It could be as bright as an entire galaxy of fusion-powered stars. At the end of their lifespans, large dark stars would have collapsed into massive black holes. This could be a potential explanation for some of the ancient supermassive black holes observed in the universe, which seem too large to have formed so quickly from fusion-powered population 3 stars, Ely says.